Okay, so hi and welcome to the experiment with activity of metals. So today we will get an opportunity to experience classifying metals into their activity series, and we have 5 metals here. We have zinc, calcium, copper, iron, magnesium, and we are going to see which of these metals are most reactive based on how do they react with the HCl and how do they also get displaced in solution. So for example, if copper is more reactive than iron, then we expect that if we put copper in an iron solution, then it's not going to displace the iron. But if we put iron in a copper solution, then iron is going to displace copper from the solution and form the copper solid and an iron solution. So let's begin with, we have here 5 different test tubes, and they all have 1 milliliters of 6 smaller HCl. I am going to put each of these, I'm going to put each metal into each of the test tubes and just observe what's going to happen. So for calcium, we are going to remove it from metal ion solutions, but instead of using the metal ions, we are going to use water. So with calcium, I'm just going to taste it with water and also HCl. So let's begin with calcium. And we need a tiny bit amount we can get. Only a tiny bit. So if I can grab this. Alright, so I'm dropping this into a HCl. So that was calcium. And I will bring this here. No. Alright, so what I can say I'm observing here is some fizzing. I know that there's some reaction taking place. So you should be able to write an equation of what's happening in the solution when calcium is put in HCl. Awesome. Now I'm doing the same thing by putting calcium inside of water. A very tiny amount. Here we go. This is water and this is calcium. And we kind of see the same result. We see some fizzing. It looks like a gas is being emitted. And our white sodium solid is getting dissolved. So from these descriptions, you can write them as your observations and be able to explain what is happening when calcium is put in water. Now that we're done with our solid calcium, we are going to do next copper. And I'm going to put copper in. So the rest of the liquids here are HCl. So the rest of the metals, I'll just be putting them in HCl solution. So this is copper, and I will also take a tiny piece of copper metal and I'll drop it in a HCl. Alright, let's see what happens. So this is copper in HCl, and it looks like nothing special is happening. So you should be able to tell why this metal is just sitting in the HCl. So for example, I would record that as a no reaction or however you want to classify it. And then I'm going to do the same. Take some iron. So we are looking at the color, at what's happening in the solution. Are we emitting any gases? Are we forming any anything. So this is iron, and I'm going to drop it again in HCl. I need a better something to push this down. Okay, so this is iron in HCl. As you observed, the initial color is gray, and as we can see again, nothing special is happening. Well, actually there's something happening. We have a decolorization, and we have very tiny bit of bubbles forming. Okay, so if you can see, we had a gray solid when we put it in here. Now we have bubbles forming, and the gray color is being changed slightly to almost whitish, and so you should be able to tell what's happening in this reaction. Alright, so we'll move next to magnesium. And I'll just do the same thing, obtain a small amount. Put it in HCl. Okay, this is very interesting. Vigorous bubbling. The test tube feels warm, and then all our magnesium has disappeared. All right. Finally, we have zinc. We'll do the same thing. Put some of it in HCl. A lot of bubbles are being formed. Some gas is being emitted. And our zinc, which was gray in color, let's see what's happening to it. You still see the fizzing and emission of a gas. And it looks like the solid is being dissolved in the solution. So again, that should tell you what's happening in the solution. So we can rate the reactivity of all these 5 metals in HCl based on the descriptions that we just that I just gave you for each of them in HCl. So now we will move on to testing reactivity with other metal ions. So for example, taking calcium sulfate. Where is my calcium? Actually, this is calcium nitrate, and I'll do the same thing. So put 1 ml of this 0.2 molar calcium nitrate into 5 test tubes, and I'll use this here. Alright, so let's obtain Let's obtain 1 ml of this into each of the test tubes. Okay, so this is calcium nitrate, 1 ml in each test tube. And now, because I only have 4 metals to test, I'm going to need 4 test tubes and not 5 as before. Well, one thing I can tell you for sure is that we saw that we eliminated calcium in this metal ion solutions, and that should kind of give you a clue of how reactive this metal is. But anyway, let's go ahead and do the same thing. So we're going to start with copper this time round and put a tiny bit in our calcium nitrate solution. Fold it more. So I don't know if you saw how the copper ion looks like. It's shiny. So I'll take a small strip and drop it in here in the calcium nitrate. Well, nothing's actually happening. So for something like that, I'll just write no reaction. Now go ahead and do the same thing with iron. So again, if we expect that calcium is highly reactive, then we don't expect these other, highly reactive compared to these other metals, then we don't really expect to see it being displaced in its solution by the other metal ions or the other metals. So again, let this go all the way. Nothing's happening, but we will let it sit for about 3 minutes and come back and see what happened. But just the first few seconds, we don't see anything happening. We will go ahead and do the same thing for magnesium. Got these gray pieces here. Magnesium, same thing. Nothing's happening. All the solids just settled at the bottom. And lastly, we'll do zinc. Zinc and calcium ion. And again, we will let it sit and observe what happens to it in a little bit, but it just looks like nothing special is happening. Okay, so we are done with looking at how the 4 different metals react when they are put in a calcium nitrate solution. So we will go ahead and test again the 4 different metals being reacted in four. So let's go with the calcium sulfate solution. So I'll put 1 ml of 0.2 molar calcium sulfate into 4 different test tubes. Observe the color of calcium sulfate. It's bluish in color. And so we'll be looking at change in color of our metal or change in color of the solution in order to rate the reactivity of the metal with the metal solution. So for example, if there's any metal that will change the color of our calcium ion, that means if it displaces the calcium from its solution, then that metal will be more reactive compared to copper. Okay, so again, let's begin this by adding copper itself. So you can say copper. Let's see if copper itself displaces a copper ion in solution. So I'll fold my my metal and drop it in solution. We still have the blue color. And we still have our copper metal just sitting in solution. So I would basically say that it's just in its own solution. So moving to iron in copper solution, obtain a tiny amount. In solution. Oops. Let's put this all the way inside. Okay. Iron metal. This was grayish in color. Now it looks like it's turning to a different color, brownish color, but we still have a blue solution, so maybe let it stay for a little bit longer. But as you can see, it turned color from gray to brownish, so that should tell us the reactivity of iron in copper solution. Then we are moving on to magnesium. Obtain some magnesium in copper solution. Okay, so this is interesting. We see bubbling or fizzing, and then so it looks like there's some gas being emitted here. The test tube doesn't feel any different. But basically there's some reaction going on. And we'll let it sit for about 2 minutes and we'll go back and see the color of the solution that we have. In the meantime, we'll go ahead and add some zinc to the copper solution and do the same thing. Just observe what's happening in solution, what's happening to the zinc color, and what's happening to the copper 2 color. Okay, this is very interesting because the copper 2 sulfate, which was blue, is now colorless, and all we have is some black solids. So that should tell us that there was some reaction that happened in this test tube. And now the color that was blue is kind of greenish, and we have a gray solid. This was when magnesium is added to copper 2 sulfate. Okay. So now based on the different metals we added, so there was no reaction when we did copper and iron, but there was some reaction when we added magnesium and zinc. So that kind of tells you that magnesium and zinc would be more reactive than copper. But then between magnesium and zinc, who is more reactive than the other one? So this is kind of a puzzle that we are going to find out what wins. Alright, so we are done with the copper 2 sulfate, and we will move down to iron 3 nitrate solution. We'll do the same thing. So we need 4 different test tubes that have 1 ml of the iron 3 nitrate. Again, we will be looking at the color of our solution and the color of the metal when we put inside the solution, and see if anything changes. So let's actually put this here. Let's create more space. Here we go. Just the same thing. What is copper doing in iron solution? And how does iron react in its solution? And how does magnesium react in an iron solution? Let's put this all the way down. Okay, here we have copper inside of iron 3 solution. I could say that nothing's happening, no reactions taking place. So that's done. Iron. Okay. Iron in iron 3 nitrate solution. Let's see what's happening. It looks like nothing's happening. So of course we don't expect iron to displace iron. It's already in solution. Now let's see what happens to magnesium when we put it in iron solution. I hope you can all see that it's producing some gas that's bubbling or fizzing. We can see the slight change in color as you can compare these two. So this one is turning more brown. Okay. And so there's some reaction, and that means that magnesium is probably displacing iron from iron nitrate solution. And finally, let's see what's happening with zinc. Zinc and iron, who's more reactive between zinc and iron? If zinc cannot displace iron, then we don't expect that it's more reactive. So there's an interesting thing happening here. We may not see any fizzing or bubbling, but the color of a solution is brown. It's dark brown. We still have some gray solids from the zinc, but then there's definitely some reaction happening here. Okay, so we are done with iron 3 nitrate solution, and we are remaining with zinc and magnesium. And for now, we'll go ahead and use our magnesium. So let's put this here. Okay, so I am going to put 1 ml of magnesium. This is 0.2 molar magnesium nitrate solution. So again, just get 1 ml of each. Or 1 ml into each test tube. Again, just the same thing. This is copper in magnesium nitrate solution. As you can see, in the first few seconds, nothing's happening. So, copper did not displace magnesium. And that means magnesium is stronger, or let's say it's more reactive compared to copper. And how about iron? This is now comparing iron versus magnesium. And if you were here in person, I would ask you to predict what would be more reactive based on what we've done before. We were able to put magnesium inside of an iron solution and we saw some reaction. And so if it was reactive, then we might expect that iron is not going to be as reactive with magnesium, but let's see. Will iron displace magnesium in solution? And as you can see, our iron metal is just sitting in solution Nothing's happening, nothing's getting displaced, no colors are being formed or changed. So that's our conclusion. Next, putting magnesium in magnesium. So magnesium metal in magnesium solution. I would say, of course, magnesium will not displace magnesium, so it's just sitting in solution like the magnesium ion. So here we don't see any reaction, no color changes in solution. And finally with zinc versus magnesium, I think this is what we wanted to find out. Alright, interestingly, the zinc is just sitting in solution as well. So it looks like we have a gray solid inside of the magnesium nitrate solution. So we can conclude that zinc does not displace magnesium, and that should tell you the reactivity between the two metals. Okay, so we are done with comparing the reactivity of the 4 different metals in magnesium nitrate solution. And finally, we want to see how the 4 different metals are going to react in zinc nitrate solution. So any metal that reacts with a zinc nitrate solution will know that it is more reactive than zinc. And so let's just go ahead and confirm or see what happens. So 1 ml of 0.2 molar zinc nitrate into each of the 4 test tubes. Awesome. So this is our last part of this experiment. And let's go ahead and determine what happens. Now I'm taking another ion, this is copper metal. I'll fold it and drop it inside of zinc nitrate solution. Okay, our copper ribbon or metal is all the way in the solution. No bubbles forming, no color changes to the metal, and no color changes to the solution. So no reaction. Going with iron. Do you think iron is more reactive than zinc? Will it displace zinc in zinc nitrate solution? Let's find out. So, drop iron inside zinc nitrate. The initial color was gray, no bubbles forming, no color change to either iron metal or the solution, which was colorless, and it's still, so no reaction. Great. Now let's go to magnesium versus zinc. Okay, I kind of have a prediction that's going to be more reactive, but let's put in the magnesium and see what happens. Okay, well, I guess no reaction. no color change, no bubbles form, no change to the temperature on the test tube, so no reaction. And finally zinc on zinc. So no color change, zinc powder just stayed in solution. And no bubbles are forming. So again, no reaction. Cool. We are done, and now based on the different observations we have made, we will be able to rate which metals are highly reactive compared to the other ones, and then we can look at how these metals are arranged on the periodic table based on their displacing other metal ions or their reactivity with HCl, and for calcium its reactivity with water. So that's it for this experiment, and I hope we will figure out who's more reactive in this activity series.